Hi everyone. Hope you had your coffee. Are you ready to hear the next talk? Let's hear it. Okay, pretty good, pretty good. Well, I'm gonna start by saying that I absolutely love TypeScript. I love working in it. It's probably my favorite language, but yes. And I'm guessing, here you like it too, which makes sense. That's why you came to this talk. But there are times where it feels like TypeScript's main goal is to delay my release at all costs. For example, my code is working, everything runs without errors, but TypeScript for some reason forces me to fix stuff that isn't broken. So what do? I get desperate and I go for one of these bad boys here. And this probably sounds familiar. Raise your hand if you've done something similar in the past. So slap a TS ignore and promise yourself, I'm gonna fix this after the release, right? But it's these small frustrations that we feel with the compiler when we try to do the release and it doesn't allow us. If we change our perspective just a little bit, these frustrations stop being frustrations and become, let's call them, interesting insights. So it's all about perspective. So let's start with the story about perspective. Imagine you live in a cave and your neighbor in this cave is a dragon. Now, you and this dragon, you don't always get along because the dragon has a nasty habit of having fire-breathing frenzy days. It just goes around and starts spewing fire all around their cave, as you know, dragons do. And it gets pretty hot, of course. So you dislike the heat and you start disliking the dragon. But what you don't see is that the dragon is really not spewing fire for nothing. He's protecting you from dangerous monsters trying to get into your cave and eat you, probably. All you feel is the heat, so you start to dislike the dragon without knowing what it's doing for you. Well, in this analogy, you are you. The dragon is the TypeScript compiler. What? The heat is the small stuff you feel when TypeScript is bugging you. And the zombies are all the things TypeScript thinks about for you, and I don't just mean type checking, that you aren't even aware of, which is our today's topic. The talk's title is Treat the Compiler with Compassion, and after today, that's exactly what I hope you do. Thank you. Right, but what do I care about how you treat the compiler? Well, I do care because I'm a big compiler fanboy. I got hooked by building my own languages back in school, and today I work with Miho, who is also here, in WASP, building a new web framework which also features a compiler. And putting all of that aside, I'm a big fan of programming languages. My favorite ones are those with amazing type systems, like TypeScript or Haskell, which I teach. But getting back to TypeScript, when I'm working with TypeScript, I don't always look this happy. Sometimes I look more like this. And this is not a good look for me, obviously. I prefer being happier, so I decided to get to the bottom of it. I decided to figure out what makes TypeScript so frustrating for me. And if you want to avoid looking like this, if we all want to avoid looking like this, we must ask ourselves, why do we get frustrated? And the answer is simple, because we don't get what we want. And we want a lot from TypeScript. We want much more than is probably good for us. And speaking of which, TypeScript actually knows what's good for us better than we do most of the time, but I'm getting ahead of myself. Let's first analyze what is it that we want from TypeScript. And the best way to do this is to look at the code example. So here's some JavaScript code, which is valid JavaScript, but crashes in runtime. There's a mistake here. I'll give you a couple of seconds to find it. It's a classic one. We misspelled month as moth. So we want TypeScript to flag this error, right? And when we fix the typo, we want the error to go away, of course. Nothing groundbreaking so far. If the code has type errors, we want TypeScript to report them, and we don't want TypeScript to invent errors that don't exist, of course. And the last one is going to sound most basic, which is we don't want the compiler to crash or hang indefinitely. These are the three features we need and we want, and it's safe to say we want them consistently, which just means that always report all type errors, never report the errors that don't exist, and always finish execution successfully, don't crash or don't hang. Now, looking at these three things, you might say, well, it doesn't really sound like much. It sounds like the bare minimum you'd expect from something that calls itself a compiler, right? But interestingly enough, they're much less common than you think. And we even have a fancy mathematical name for each one. For example, if a compiler finds all type errors always, we say it is sound. If it never invents type errors that don't exist, we say it is complete. And if it never crashes or hangs, then we say it is decidable. They're fancy terms, it just means the same thing. And these three properties are very useful in classifying languages in their compilers. So it's useful to put them on a Venn diagram. So once again, we have soundness, which means that if the code has type errors, compiler will always report them. Complete compilers never report errors that don't exist. And decidable compilers never crash or spin indefinitely. And we can fit all languages, all compilers somewhere on this diagram. So fun fact, they can never be in the middle. So the middle is theoretically impossible. I won't go into the proof now. It's interesting, but we can do it in the questions session. But they all strive for the middle and end up somewhere in the circles, most languages having two properties. And now I want you to think for a couple of seconds and think where you would imagine TypeScript fits on this graph. So think about what you know about the language and where you expect to find TypeScript. Well, since I've been saying how amazing the compiler is, it makes sense that TypeScript is, of course, right here. Completely outside of all the desired properties we've covered so far. Which actually means that TypeScript often finds type errors, but might miss some of them. Never, sometimes even reports errors that don't exist, and sometimes either crashes or hangs. And getting back to our frustrations, this kind of makes sense, because we get frustrated when TypeScript doesn't catch a type error we get in runtime, which happens because TypeScript is not sound. Or we get frustrated when we have code that works, but TypeScript doesn't allow us to ship it, which happens to me and happens because TypeScript is not complete. Or we straight up break the compiler, which happens because TypeScript is not decidable. Well, to be fair, the last one doesn't really happen all that much anymore. TypeScript is pretty mature, so I won't be discussing decidability today. But the first two do happen, and they do cause frustrations. And I told you that I would convince you that these frustrations, with the right perspective, can be seen as not flaws, but something we should be happy the language has. And I still stand by this. So let's start with the more outrageous one and explain why TypeScript is not sound. It's a great question, right? Because you're making a type system. Its main purpose is to catch type errors. But suddenly, you don't want to catch all of them. I mean, why? It's easy to think that this was a mistake. Making compilers is hard work. So someone on the team probably slipped in a bug. The compiler became unsound by accident, and when they noticed, it was too late to change it. But it's actually much more interesting than this, because TypeScript is not sound on purpose. And they set out to not make it sound from the very beginning. I can actually prove this, because I don't know if you know, but TypeScript's GitHub has a non-goal page, where the team lists all the things they don't want TypeScript to be. So this is what they explicitly try to avoid in the language's design. And I want to direct your attention to the third thing, where they explicitly say, we do not want to implement a sound type system. Why though? I mean, it sounds ridiculous, right? You're making a type system with the very purpose of catching type errors, but from the get-go you say, I don't want to catch all type errors. There's a very good reason for this, actually, and you can probably guess the reason, because it's always the same reason. It's a trade-off, right? To understand what we're trading off, it's best to look at an example. Let's say we're modeling countries, and each country has a name and has a capital. Except there's something wrong with our model already, because some countries, in fact, don't have capitals. So let's just fix that real quick and make the capital nullable. By the way, I know you're all wondering which country doesn't have a capital. Does someone know this? If you know this, you can raise your hand and get a B as a prize.
The Vatican?
No, the Vatican is actually the Vatican.
No.
Yes, exactly. You win the B.
Thanks.
I'll remember you. Come talk to me after the talk. Right. And let's say we want to make a function that's making some travel plans, right? And we call the function go to capital of. The function receives a country, checks whether the country has a capital, and if so, applies for a visa for said country, and console logs the capital, where we're going. We're very excited for the trip, so that's why the capital is in uppercase. And apply for visa thing just does some serious visa stuff, whatever that means. This is the complete system. We can use it to call it with countries that have capitals, like Romania, or countries that don't, like...
Nauru.
Exactly, yes. So let's see if our code works in the TypeScript playground. This is the exact same code we had on our slides, right? And when we run it, what do we expect to see? Where for this line, we expect to see going to Bucharest, and for this line, we expect to see nothing. We run it, and the code does exactly what we expect. Why does this work? Well, because capital, even though it can be both a string or a null, at this point, TypeScript knows it can only be a string, and you can see it from the hover window. It knows this because we eliminated the null option earlier in the function. But if we were to do something like this, TypeScript would rightfully complain, right? Because now capital is no longer a string, it's obviously null. But here's where it gets interesting. Watch what happens if I take this snippet and move it into the function. So we don't get a type error this time, and sure enough, if you run the code, we get an error in runtime. And this is a textbook example of TypeScript not being sound. So there is a type error, but TypeScript didn't catch it, and it made its way into the runtime of the code. And why does this happen? I told you it was done on purpose, so let's see why it was done. Could this have been sound? The answer is absolutely. So all they had to do to make this sound is to say, after you send an object to a function, all bets are off. I'll forget everything I know about the type and invalidate any narrowings I might have made before it. But they didn't do this, and they didn't do this on purpose. Because this pattern, where you check whether something is null and then do a bunch of calls to just read the data or send it somewhere, is so common in JavaScript, while this thing here, where the function actually mutates something, is so rare, or at least you want it to be rare, that the team decided that it doesn't really make sense to make 99% of the code more verbose to catch that one edge case where you actually something like this would happen. And to drive this point home, let's go back to the slides and see this is what we write now. And if the apply for visa function really did, if every function call really did invalidate the refinement from the if statement, our code would have to look like this, which doesn't look so bad when it's just a single thing. But you often call multiple functions in a row like this, which you, again, can do because each call won't invalidate what you know about a capital. But if it did, your code would have to look like this. And 99% of the time, all the checks are unnecessary. For example, this never was a problem for me, this issue that the capital is set to null. So the trade-off was made, and they sacrificed a little bit of correctness to get a lot of practicality. And this is far from the only example of this in the language. They made a lot of these decisions. If you're curious, you can go around their GitHub, and there are issues where the discussions are very interesting. It's so common, I could spend an hour talking about all the bugs I found in the compiler, right? That weren't really bugs at all, and I'm not the only one. So they actually have an FAQ page where they list all the bugs that aren't bugs. And if you ever file the TypeScript issue, they actually make you read this before filing an issue, because they keep getting people reporting stuff they made unsound on purpose, telling them there are bugs. And each one of these decisions comes down to the same thing. It's sacrificing correctness for practicality. You can think of this stuff as a dial, right? So when you're using JavaScript, there's no soundness to speak of, really, because there's no type system. Then when you activate TypeScript, the dial kind of jumps to the right. But the team knew that not everyone has the same preferences. Some people value correctness, some people value practicality. So they added a couple of dials to tweak the dial, to move it either left or right, depending on what you prefer. The most famous is strict mode options, which if you enable, the dial jumps even further, even towards the correctness. And this is actually the point where they recommend, the TypeScript team recommends you start the project. Beyond the strict option, there's a couple of other ones which aren't included, like unchecked index axis, which moves the dial ever so slightly further to the right, closer to soundness. And this is the best you can do with the compiler, with the vanilla compiler. But if you're willing to bring in some extra help, like for example, TypeScript ESLint, you can go even further closer to soundness. Yes, we have the creator here, so give a round of applause for Josh. And if even that is not enough, and you're happy to sacrifice even more practicality for even more correctness, you can use something like TS-reset, which will actually override some of TypeScript's core type signatures to make the language more safe. But notice that whatever you do, you really can never get to the sound part of the dial. So with all of this turned on, this example from before still won't be caught in compile time. And hopefully I've convinced you that this does make sense. And if you're still on the edge about that, just remember this monstrosity and think about it living in your code base. So that, I think, settles soundness. Fair enough. You want to risk some correctness to get some practicality. OK. But what about the other way around? And this is the one that's really more frustrating for us. Why do I have to fight the compiler to convince it that my code works so often? Why is TypeScript not complete? Also a perfectly valid question. And you already know the answer, so I won't tease it this time. Again, it's a trade-off, but a slightly different trade-off. So again, let's jump straight to the example to see what exactly we're trading off. Say you have two functions. We're still in our country theme. Say you have two functions, one for setting the population and the other for setting the language of a country. The types are both, respectively, number and string. This here is perfect JavaScript code, perfectly valid JavaScript code. So there's no type errors, and this always works. But as soon as you activate TypeScript, you get not one, but two type errors here. And I mean, what's going on? The code works, so why am I getting an error? Well, inspecting the types, you can see that TypeScript actually infers data to be a number. And then later, when you try to assign the string to the variable of type number, you get an error that says string is not assignable to number. But again, what's the point? I mean, the code always works. Why can't TypeScript figure this out? It can figure it out, but it will require some compiler wrestling. In this case, it's not too much. You just need to tell TypeScript explicitly that data can be either a string or a number, and the errors go away, right? Again, we have to ask ourselves why. If we could do this, surely TypeScript could just look at how we use the data, see, hey, this guy is assigning a number to the data, then he's assigning a string to the data. Obviously, he wants it to be either a string or a number. And could TypeScript do this? The answer is absolutely yes, it could. There are languages that do it. For example, Haskell does this. You look at all the places where you use the variable and decide on its type based on its usage. But they decided not to do it. They decided to only look at the assignment to infer the type. And they did this for two main reasons. And those are that this pattern, while pretty common in JavaScript, is also common foot gun. So they decided to use the compiler to nudge your programming into the right direction. You're better off having two variables for stuff with different types anyway to avoid bugs. And the second reason is that even though you could go through all the places where you define, where you use the data to see what its type was supposed to be, this makes the code much more difficult to reason about. So they purposely made the compiler a little dumber to simplify our code bases and make the code more readable. Which again, in my eyes, having worked with Haskell, I think is a pretty valid trade-off. Hopefully this covers both why TypeScript is not sound and not complete, and they're kind of opposite trade-offs. So one sacrifices correctness for practicality, and the other sacrifices power for simplicity, right? But one thing that's very important to emphasize here is that knowing about these things does not give us a TypeScript is stupid pass. So we shouldn't just be going left and right, casting stuff, asserting types, thinking, okay, this TypeScript is throwing an error, this is definitely TypeScript not being complete. I'll just tell it that I know what I'm doing. Because at the end of the day, most of the confusion in the language still comes from our own misunderstanding. And I'll give you an example of this, which tripped me up for the longest time. It has to do something to do with object.keys. Some of you probably know what I'm talking about. Raise your hand if you do. OK. So what's the deal here? Let's go back to our country example. And let's say this time we want to log countries. So we want to do something like this. Let's implement a simple logging function. The function takes a country, of course. It gets all the keys out of the country object. In this case, that's the name and the capital of the country. And then iterates over the keys and logs each key and each key's value. Sounds simple enough, doesn't work. TypeScript tells us that it can't use string to index the type country. Why does this happen? Well, obviously because TypeScript thinks that country keys is an array of strings, and you can't use a generic string to access an object whose fields are known, which doesn't have an index signature. But the question is, why didn't TypeScript infer country keys, at least that was my question, to be something more specific, like a name or capital, like an array of stuff that can be a key of a country, which is exactly what we're doing, right? And I thought that this was a classic case of TypeScript being incomplete, that this is a type error, which is a false positive, and all I have to do is cast object keys to be a key of string array, right? Key of country array. But no, actually TypeScript is 100% right to complain here. And to understand why, we first have to understand that the country type does not really enforce what the object doesn't have. It can only enforce what the object does have, in this case, the name and the capital. And there's nothing stopping us from doing something like this, right? We can always send a richer object to the function than required by its type signature. And when we do it, the runtime value of country keys is no longer exclusively just the keys of the country interface. It can be anything, any possible string at all, depending on what we send to the function. So TypeScript was right to warn us. And I only learned this, I'm ashamed to say how recently I learned about this and why this happens, even though I thought I know all about the type system, right? The point here is that there's a lot of this stuff. And by this stuff, I mean features of the language that make perfect sense, but only once you actually take your time to learn them. And obviously, I can't cover everything in this talk. You only saw 3 examples of it, and there's countless. But what I can do is recommend this book here. I'll give an applause for the book. It's a great book. Thank you. And it's probably my favorite TypeScript book, full of practical examples and just enough theory to make you understand these examples. I think I've read it twice, and it helped me tremendously when making this talk. It has great examples, makes this stuff very, very understandable. Until you read the book, I'll just say this. Even though TypeScript is not sound, and which means that you will find runtime errors which should have been caught in compile time, and even though it is not complete, which means that yes, you will have to fight the compiler sometimes to convince it that correct code is well correct, most of the time TypeScript still has our backs, right? We are probably the ones who don't see the bigger picture, and the compiler is our friend. Thank you.